Okay, folks, welcome back. Sorry there was so much time between this video and the last video, but I had a lot of emails come in, and now I'm getting a little bit of a break. This is the problem that we finished up on, which was the vanadium oxide, which you see the formula here. Now we're going to do problem number 2, so let's go ahead and get it ready. Move this out of the way. Alright, we are going to calculate a compound that contains, sorry it's taking me forever to erase this, I'm just hitting the undo button. Alright, a compound that contains 10.52 grams of nickel, 4.38 grams of carbon, and 5.10 grams of nitrogen. So, once again, these are already in grams, which is nice. So, let's just go ahead and start our columns. We have nickel, we have carbon, and we have nitrogen. Alright, so let's write their masses that was given to us underneath them. Oh, got a new message again. Whew. Alright, I'll try to answer that later. Anyway, we need to write down this 10.52 grams underneath nickel. So we have 10.52 grams. We got a lot of requests in, so I get a lot of email. So we have 10.52 grams of nickel. We have 4.38 grams of carbon. And we have 5.10 grams of nitrogen. Now, first thing I'm going to do is convert these guys to moles. So I'm going to divide them by their individual molar masses. Now remember, I need a periodic table to do this. Here's my periodic table. Nickel is 58.69. 58.69. I'm sorry I repeat myself, but I do that so I can remember the numbers as I'm trying to write them down. 58.69. Carbon, as you can see here, is 12.01. So let's go back. It's 12.01. 12.01. And nitrogen, looking back at the table, is 14.01. Yay! Alright, 14.01. And that's grams on these. That's grams of nitrogen. That's grams of carbon. It's actually their molar mass, so that's actually grams per mole, and this is grams. Alright, so let's punch them into a calculator. Okay, I'll turn on my TI-83 Plus. That's virtual. Type in 10.52 and divide it by 58.69. Now this is the number of moles. Now I'm going to keep 4 sig figs because I have 4 sig figs on this one. That's 0. What was that? I didn't get it all. 0.1792. So 1792. Okay. Now let's do the carbon. That's 4.38 divided by 12.01. On this problem, I only have 3 sig figs because of the 4.38. So I'm going to write down 0.365. Yeah, 365. So 0.365. Okay, time for nitrogen. On the nitrogen, I'm going to take 5.10 and divide it by 14.01. Enter. Once again, 3 sig figs on this one, and I have 0.364. 0.364. Now, let's make sure I wrote those down. Now, ironically, this number is really close to the number that we just wrote down on the carbon. Now, the reason why it's kind of ironic is basically just this. These two numbers are really the same number. Now, let me try to defend the reasoning behind why they're really the same number. for one, if you look at the periodic table that I'm using, it's not the most exact periodic table in the world. It only goes out to hundreds. Okay, and if you look at these two numbers, they're only different in the, well, tenths, hundreds, thousands. They're only off by 1/1000. So really, these two numbers are one and the same. And if you really look, this is the number that's the smallest number. Basically, if you covered up this 2 right here, you'd see maybe the number 179, which is, we could say like maybe 179, and this is like 365, and this is 365 or 364. But the thing is, this is the smaller number over here, even though it has more digits, because if you added a 0 here, you could see, 3650, which is like 3650. And same thing here, 3650, or you could say 3640, which is really the same number, okay, because we went over this. So let's divide by the smallest number, which ironically is going to be the 0.1792. Okay, divide them by that. 0.1792. Same thing here. 0.1792. Now, what's funny is this gives me a 1 right here, which is what I wanted to begin with. This is 1 nickel. Now here, it kind of looks like a 2, but I don't know until I punch it in on the calculator. So let's punch it in. 0.365 divided by 0.1792. And lo and behold, I get 2.04. And that's really close to being the number 2. So this is 2 carbons here. And that's going to be the same thing, the same result here for the 0.364. I divide it by the 0.1792. I end up getting 2 as well. So this is also 2 nitrogens. So the formula that I get here is basically NiC2N2. I'm going to be honest, I have never seen this before, and this is probably the reason one person sent it to me. Maybe they were having the same issue as I was. It's not coming up pretty at all. It's coming up rather ugly, but according to the math, this is the answer. So like I said, I don't understand why it's coming out a little bit rough. Maybe the periodic table I'm using is kind of rough, or maybe the creator of the problem just used too many digits, or maybe it was typed down wrong or something like that, or maybe I've made an error. But he should have, or she should have, gotten the same answer, and I can understand their frustration when you look at this and everything. But anyway, this is, remember, this is the method of finding the empirical formula, and it's just, I hate to say it, it's a tool to give us a rough, it's a very good attempt to get us the formula, but if you are not using a precise tools to get these numbers, careless lab errors, careless reading errors on the scales, or just some little something, just copying the problem down wrong can cause problems like this. Because I believe that this formula is probably really like this. It's probably nickel 2 cyanide, which would be Ni parentheses Cn for the cyanide ion, and 2 on the outside. I bet you this is the way it's supposed to really look. If I was going to do my gut feeling, because anytime that I see carbon and nitrogen together, I know that's a cyanide, Cn, and it's a polyatomic ion, and it's on the back of your periodic table sheet, that at least the one that I give my students. So, and anyway, that too does make sense for nickel, because nickel does carry a -2 charge, and I've got it listed on the back of this periodic table. and there it is. Ni does carry a +2 charge. And notice that cyanide is right here at Cn negative. So I'm feeling a little bit better about the calculation, even though it seems a little bit off. It's kind of weird because you did not get like 1.999 or 2.0001, but not too bad. But this is nickel 2 cyanide, and I feel pretty confident in the answer. But if any of you want to critique it and, bash it, just go ahead and let me know, and I will do my best to make it right. Anyway, guys, y'all have a good night, and I hope this tutorial was helpful. Just remember to check out the other ones. You have a good night.